Hello everyone and welcome to Ask a Scientist. We will be discussing today Canada's changing climate. And just a quick note about this today's panel, it will be only in English since our scientists are Anglophones, but please don't be shy and ask your questions in the language of your choice in the comment section below. You can do that either on Facebook, Twitter, YouTube, or LinkedIn. Oh, sorry about that. Okay, yeah, so you can do that on Facebook, Twitter, LinkedIn, and YouTube. And what we'll do on our end, we will translate it and then answer it back in English. Le panel d'aujourd'hui va se faire uniquement en français puisque les scientifiques sont avec nous, sont anglophones. Vous pouvez poser vos questions dans la langue de votre choix dans la section de commentaires qui se trouve en dessous. Vous pouvez faire ça sur Facebook, YouTube, Twitter et LinkedIn. Ce qu'on va faire de notre côté, nous allons la traduire pour ensuite y répondre en anglais. Et ensuite, après le live, il va y avoir une version sous-titrée en français qui sera disponible sur les réseaux sociaux. Today, you will get the opportunity to ask questions to scientists that worked on Canada's Changing Climate Report that was published in April. And yeah, so without further ado, hello scientists, how are you doing today?
Good, thank you.
Yeah, good. Amazing. So here we have Chris Flato, who is a research scientist at ECCC. Can you tell us a little bit about your work for environment?
So it's Greg Flato.
Oh, sorry. Oh, sorry about that.
So I work as a research scientist in an area of global climate model development. So we build computer models that simulate the global climate and make projections of how the climate will change in the future.
Okay, cool. And here we have Elizabeth Bush, who is a climate science advisor for ECCC. And you two, can you tell us a little bit about yourself?
Thank you very much. I work in Climate Research Division. I get to work with Chris and Greg and the other research scientists that we have in the division. And yeah, my job's a little bit different than theirs. So they're a research scientist, and my job is as a science advisor, which means that I work with the research scientists and we work together to communicate the science that they're doing and also the understanding of the science that's out there generated by the community at large, and we try and communicate it up within government so that everybody is informed about climate change.
Amazing. And my friend over there is actually Chris. His name is Chris Dirksen, who is also a research scientist like Greg for environment and climate change. Can you tell us a little bit about yourself?
Yeah, sure, that's right. So my research involves the use of satellite data primarily to understand how snow and sea ice are changing across Canada and across the Arctic. So one of the more fun, enjoyable parts of my job is that we do go into the field. We make measurements in the Arctic so we can how snow and sea ice are changing across Canada.
Amazing. Thank you so much for being here. And anybody?
Well, I'm holding the mic, so
Yeah, so
I'll start talking first and I can pass it down the line. So I think what's really unique and important about this report is that there has previously been work done that shows how climate across the world is changing.
Okay.
But what we did for the first time was synthesize and distill the information down for Canada, for Canadians, how at the scale of our country, how and why the climate has changed in the past and what the different pathways are for how we can expect the climate to change in the future.
Amazing.
I'll pass the mic down.
Anybody wants to add something?
This is really a groundbreaking report because it was the first time that we've done such a comprehensive report about how Canada's climate has changed. And I think, like Chris said, what really makes it a resource that will be important to Canadians is that it brings together so much information. So about snow and ice, about changes in temperature, about changes in the ocean. So it's kind of a one-stop shop where Canadians can go for information about climate change in Canada.
Sure. Yeah.
Maybe just to add that the information that we provide in this report is drawn primarily from what we call the peer-reviewed scientific literature. That is scientific literature that's already been through a process of careful evaluation and checking by other scientists. And what we did in this report is take all of that information that's available, already published, and synthesize it and assess it specifically for Canada. So it really is authoritative information that people can rely on.
Amazing. And it's good you're holding the mic because the next question is directed to you, actually. Can you talk more about some of the severe weather events that can be expected in Canada in the coming years?
Well, as the climate changes, of course, the average of all sorts of climate quantities like temperature and precipitation, all of those things increase. But the things that have a profound effect or a profound impact are often the extremes in various quantities. So when you think about the average temperature increasing, it's not so much the average temperature that causes impacts, but it is the change in frequency of very hot temperatures or very long, longer duration heat waves, things like that. So we have in the report looked very carefully at what observations tell us about how these extremes have changed in the past based on observations, and using models looked at how these extremes will change in the future. And certainly the evidence is pretty clear that the temperature extremes are changing and will continue to change. That is, the hottest days of the year will increase, the number of hot days will increase. And of course, at the other end, the number of very cold days will decrease as the climate warms. We also see changes in the model projections of changes in extreme precipitation events, other extremes that are associated with the changing climate.
Cool. Thank you for that. What can we do to adapt to climate change, and what can we do to mitigate it? This question is addressed to anybody
That's
who
an
wants to
elaborate
ask.
question.
Do you want me to take this one?
Yeah,
Oh, okay.
perfect.
Well, let's start by saying that, well, the question is good because it asks about both adaptation and mitigation. So we use those terms a lot. Mitigation means reducing emissions of greenhouse gases, especially carbon dioxide, the main cause of climate change. So that's what mitigation means, taking action to reduce the cause of climate change. Adapting to climate change is really about preparing for a future with climate change and the challenges that will bring. So we can talk about at the global scale, climate change is a global problem. So from a mitigation perspective, collectively, as a world, we all need to reduce emissions because the science has clearly shown that it's the total amount of carbon dioxide, so carbon pollution as we refer to it, it's the total amount of cumulative carbon emissions over time, which is the main driver of global warming and associated climate changes. So that means that every action that every country, every individual takes will contribute to reducing that cumulative amount of carbon pollution. So that's the big picture story of what we need to do globally. Globally, we need to take action to get to zero carbon emissions around mid-century if we want to meet the global temperature targets that Canada and other countries have signed on to. In terms of adaptation, there's a lot. Greg started to talk about future changes in extreme weather, and that's certainly one of the areas that Canadians and others around the world need to prepare for, because longer heat waves and more intense heat waves in the future means that Canadian cities will need to put in place cooling centers and alerts, heat alerts, so that citizens know when heat waves are coming and how to stay cool and protect themselves. We know that extreme rainfall is projected to increase. So again, like all the infrastructure that we have needs to be designed to deal with more intense rainfall events in the future. And we could go on. So I'll pass it to Chris in case you want to know you were good for now. And I'm sure we'll talk more about it as the conversation develops.
Yeah, of course. Thank you for that. All right. So what can I do as a regular Canadian to address climate change? What can everybody do?
Well, as Elizabeth said, there's two things. There's the mitigation side and the adaptation side. So on the mitigation side, as Elizabeth pointed out, it means reducing our emissions of carbon dioxide and other greenhouse gases into the atmosphere. And many of the things that we do have associated greenhouse gas emissions. And when you think about the energy that we use for lighting, for heating, for transportation, all of those things are associated with greenhouse gas emissions. So we can all individually make choices about how much we drive, how much we heat and cool our buildings, whether we turn the lights off, how we dry our laundry. All of these things are small individual choices that we can make to reduce our greenhouse gas emissions, and that then scales up to larger and larger dimensions. So as a city, many cities are involved in making plans for how they can reduce their carbon footprint. Countries are implementing policies and plans for how to reduce greenhouse gas emissions, and that scales up to the international level.
Amazing. Thank you for that.
Can I add something to that?
Go ahead.
I think the one thing I'd really want to add is that, as Greg said, every action matters. So individual action is really important. But I think things like what we're doing today, having this conversation and hopefully engaging a lot of people in that conversation, trying to grow the conversation is really important, because individual actions certainly can count and the choices we make matter, but this is a really big problem. And we really need to see collective action at the scale of countries and all the countries around the world, and really to see support for national policies that can really make a difference in the emissions that Canada as a country, to reduce Canada's emissions, and then collectively for the world. So I think individual actions are important, but growing the conversation and getting everybody talking about the problem and to generate that collective support for action is really important as well.
Yeah, it's important to not forget that everyday action, even if it's really small, it is doing a difference. Yeah, so just a quick reminder to people at work or at home that you can ask questions on all of our platform. Either it's Facebook, Twitter, YouTube, or LinkedIn, and we will get back to you. And we actually have one question from Nicola on Facebook. The science of climate change is solid, and the proof that there are...
Do you want to take that on? Sure.
I can start the conversation on that and maybe pass things down. So I think in the context of this Canada's Changing Climate Report, it's really important for people to understand, as Greg alluded to already, that what we've done here is very carefully assessed work that's been done by many different scientists over previous years. We've looked at the data very carefully, and the evidence is very clear, the science is well understood, and the science is strong. We understand and can quantify how much warming we've experienced, both around the world and in Canada. We understand the physics of that, so we understand why it's happening. And based on the climate models that we use, including the one in Canada, we can understand what the future pathways are. So from a science point of view, I think the evidence in the report is very clear and compelling. So the next step beyond that is to think about how people take up that report and deal with that information. And that's part of the discussion that hopefully we're starting today and have done already over previous months, is to show people that the science is clear and compelling, and then it's up to others to take that in and do what they should with it.
Anybody wants to add something? No?
Great answer.
Okay, cool. So Danny from Facebook wants to know, okay, I hope I'll pronounce this right, but Bill Nye,
the science guy.
Okay, sorry about that. So Bill Nye says that by the end of the century, if emissions continue to increase, the temperature could rise by 4 to 8 degrees. Is it true? Will we be able to live on the planet?
So I'll start maybe just to talk a little bit about that. So the different carbon emissions pathways in the future lead to different magnitudes of warming by end of century. One of the scenarios does lead to global mean temperatures that are warmer than what we've experienced now. And what's important for people in Canada to understand is that warming is amplified in Canada. We see a larger degree of warming than the global average. So if the global mean temperature rises by, say, 2 degrees or 3 degrees across Canada, and especially northern Canada, we'll see increases that are higher than that. So these scenarios definitely, especially for northern Canada, do produce by end of century warming that is of that sort of 4 to 8 degree magnitude. And Greg, you might want to comment further.
So just to follow up on what Chris said, the extent to which the planet will warm by the end of the century is determined by the extent to which we do or do not limit emissions of greenhouse gases. So the Paris Agreement, for example, aims to limit global warming to 2 degrees or make best efforts to limit warming to 1.5 degrees. That requires very rapid and deep cuts in emission. If we don't reduce emissions of greenhouse gases, then of course the planet will warm more than that. And in some scenarios with very large consumption of greenhouse gases over the 21st century, we will see it is potential to see global warming of levels of 4, 5, 6 degrees. As Chris pointed out, one of the difficulties for Canada is that our rate of warming is roughly double the rate of the global mean. So if the global mean temperature increases by 2 degrees, on average Canada warms by 4 degrees. And so if the global mean temperature were to get to something like 6 degrees, that would mean a 12-degree increase for Canada,
Really?
and even larger for northern Canada in the Arctic. So
I did
that's
not
the
know
that's the reason that it is such a profound problem, and why there is such an urgency to begin taking emission reduction actions to avoid that kind of a future.
Oh, I see. Interesting. Thank you for that. So Irina from Facebook wants to know about the flooding in Ottawa. So does the recent flooding in Ottawa have anything to do with climate change? That's a good one. That's a good
Well,
one.
maybe I can start off on that. So it's important to understand that there is natural variability in the climate system. The weather that we see from day to day, the events that we see, like flooding events or heat waves or cold spells, those are all part of the natural climate system, part of natural climate variability. That variability is superimposed on top of a warming that is slowly increasing, and that has been observed to increase in the past and will continue to increase in the future. So these kind of events, like an individual flood or an individual heat wave, can't be specifically attributed to a changing climate, because we've had floods in the past, we'll have floods in the future. We've had hot days in the past, we'll have hot days in the future. It's the likelihood of these events, the probability of these events that changes as the climate changes. And so certain events like extreme heat waves will become more likely. Certain events like extreme precipitation events that could lead to flooding in certain circumstances can become more likely. So it's those probabilities that change, but the individual events themselves are not attributable to climate change. I don't know if anyone else could.
That sounds good. Good,
Yeah.
perfect. So on Twitter, Old Woman's Chair, that's the name. Old Woman's Chair wants to know when will the focus be on preparedness and extreme weather? When will the focus be on preparedness and extreme weather and climate events? So when will we focus on preparing for these kind of situations?
Well, maybe I'll start and pass it on. But as Elizabeth already pointed out, adaptation is something that we have to do in any case. So the climate is changing. We observe that the climate has already changed, and there's a certain amount of change that will be inevitable, because we're not going to reduce our emissions overnight.
Yeah.
So we do have to adapt in various ways, and part of that adaptation involves adapting to this changing frequency of extreme events. So we have to build infrastructure, we have to think about planning the way that we construct things, the way that we develop things in ways that are more and more resilient to those extreme events.
Well, that's a great answer, Greg. And I think the only thing, specifically the question is when do we start doing these things? And I think the answer is now. That we already are experiencing damages from climate-related extreme events. We know that many of those events will change in the future. So anything we can do now to become more resilient as a community will prepare us better to adapt to changes in those extreme events in the future. So let's get started now. And I think, for many things like buildings or planning where we put our homes and how close to rivers that might flood, we expose ourselves to flooding events in the future. We can make those decisions now, and they have there's a long time commitment to that. So if we make good decisions now, we're building, resilience for a long-term change in climate. If we make poor decisions now, then we'll be, mopping up the damages in the future. So I think getting started and thinking about the changes that will come, it's important to take action now.
I'll just maybe finish up by saying I think that process is underway now. So as part of the Canada Changing Climate Report, we've engaged in a number of web briefings. Yeah. We've invited people to engage in the report and see how the findings of the report can help inform them. Okay. We've had very good uptake, I would say. So yes. Cities, provinces, people are paying attention to the report. They're engaging with it. They're hearing more about it. They're asking us questions back. So I think it was a very good question. And I think the positive side of it is that I think the engagement is happening, and hopefully this report kind of helped motivate some of that.
I'm going to ask for the mic back, because now that you mentioned the national assessment, I would like to tell our audience that our report, Canada's Changing Climate Report, is part of a broader national assessment process. And that process is unfolding over the next few years. So our report laid the climate science foundation for this assessment. And in the coming years, there will be additional reports that will be looking at impacts of climate change and how we are adapting to reduce risk across different regions of Canada, addressed now by author teams that are writing those reports, and those reports will be available to Canadians in the next few years.
Awesome, thank you. On Twitter, eBrandy wants to know, generally, what are the most recent model-based predictions for the various Canadian provinces and territories, and how will this impact Canadian agriculture?
It's
Back
a
to
future
Greg.
climate change
Great question.
Back to Greg.
So the report is available online, and I don't know if there's going to be a link as part of this program to it, but it is available online, and you can find it by Googling Canada's Changing Climate Report. And in that report, there is a chapter on future projections, and it does provide information for all of Canada. There is information for provinces as well. The general picture is that warming is not uniform across Canada. The observed warming and the projected future warming is not uniform. What we see is that the projected warming is largest in the northwest of Canada, so the Yukon, Northwest Territories, and least in the Maritimes and Eastern Canada, and kind of a gradation across there. Impacts in terms of agriculture, which the questioner was asking specifically about, for agriculture, it's not just temperature, but also precipitation and water availability that is important. And one of the things that we see in the future projections is that although on an annual average, precipitation is projected to increase pretty much everywhere in Canada, but particularly in the north. For southern Canada and the prairie parts of Canada, the summertime precipitation is projected to decline. And you combine that with the shorter snow season, the earlier snow melt, the reduction in the amount of water that's stored in mountain regions as snowpack and glaciers, that affects the summertime river flow and therefore summertime water availability late in summer. And so that's something that is projected to have consequences for agriculture in terms of the availability of water to support that. And that will surely be one of the things that will be talked about in more detail in the additional reports that Elizabeth was talking about.
Awesome. Anything else to, no? That's good, perfect. Keep the mic. The question is directed to you. What would you say to people who claim that colder temperatures, like some regions of the country experience this winter and spring, are proof that the climate is in fact not warming? What would you say to those people?
Well, I would say that it's not proof that the climate is not warming, if I can put lots of nots in the same sentence. So as I mentioned before in response to another question on climate extremes, there is natural variability in the climate system. We have cold days and hot days, and cold weeks and hot weeks, and dry days and wet days. That will continue in the future. The fact that you get a cold day is part of natural variability. The fact of the matter is that the temperature is increasing. We observe that both globally, nationally. We see that the climate is warming, and that means that the likelihood of getting extreme hot temperatures will go up. The likelihood of getting extreme cold temperatures will go down. But that doesn't mean that in the future, even if the temperature is several degrees warmer, that you won't still get a very cold day in the winter. That's just part of natural variability, and it doesn't mean that the climate is not warming just because you had a cold day.
Good point, very good point. From your perspective, what are the most important findings of the report?
Maybe I'll pass it down.
Go
for it first.
You want me to talk
Yeah, go
first?
for it.
What are the most important findings? I think it really, we can speak to many of them, so we can all speak to things that we find most important. I think one of the most important things, well, we've established very robustly that Canada's climate is warmed, as Greg and I think has alluded to. We know it's warming more than the global average. That's a really important message. We established, and which is what the science community at large knows, that the main driver, the main cause of warming, both globally and in Canada, is due to emissions of greenhouse gases and especially carbon dioxide from human activity. That's a really important message because it means that we're causing the problem, so it means that we have to be the solution to this problem. We talked about, Greg talked about extreme events. I think that's a really important thing for people to consider, that climate change will exacerbate things that are already challenging for us to deal with. So that's a way to think about climate change. It'll exacerbate the things that make life difficult for us already. So we need to, again, adapt and prepare for those kinds of changes. And I think just finally, a really important message is that we have choices now. We are at a stage where we know from the modeling that we've done that we can either be very aggressive in taking action to reduce emissions and try to limit the amount of warming that we need to deal with in the future and all the associated changes in climate that go along with that. If we take aggressive action collectively, we can put ourselves on that kind of a path. If we don't take action now and we continue along the sort of high emission scenario, large global warming, even more amplified warming in Canada scenario, then that will really put us into a future that is dramatically different than the kind of Canada that we've adapted to and evolved our way of life around. So that will be enormously challenging for not only for us, but more importantly for future generations.
Well, maybe I'll just talk briefly about snow and ice in Canada, since that's the area of my own research focus. And I think it's important to realize that some parts of the Canadian landscape, while they will change under climate change, we will still have snow in the winter. In most parts of the country, might be for a shorter time of the year, and it may not be as deep, but we're expecting, of course, there still to be snow. There will still be sea ice in the Arctic, maybe not in the summer, but we still expect there to be winter sea ice in the Arctic. But there are other certain parts of snow and ice across Canada that once we lose them, will not come back. And in this case, I'm referring to alpine land ice, for instance. So glaciers take a very long time to form, thousands of years or longer in some cases. So the way these processes work is as these glaciers lose mass, they will not come back. And so the climate models project, we've already observed dramatic loss of mass from this ice across Canada, both in the Arctic and Western Canada. And the models project, some very serious mass loss, 80 to 90% of the ice lost by end of century. And this type of ice, unlike snow and sea ice, cannot come back. So I think that's a really important point to emphasize. This is important water supply for people, so it's really a key area.
Yeah, key message, that's for sure. How will the findings from the report be used?
That's an Elizabeth question.
How will they be used? What Greg said in the beginning about the fact that this is an authoritative source of information is really important. So that means that anybody who's trying to understand about climate change or make decisions about climate change will have an authoritative place to go for information. So that was really the purpose in doing this report, Canada's Changing Climate Report, to provide to a wide range of Canadians a robust reference source for information about climate change. So our hope is that the report will be used by individual Canadians who want to understand better, for decision makers in local government, engineers who are trying to build for the future. They will need to have not necessarily the specific information that they need to design a new sewage pipe or a building. That's Climate Services, and Environment and Climate Change Canada is establishing a program to provide better climate services. But our report provides a source of information to really lay out what we understand, what the current state of knowledge is about how Canada's climate has changed, and the fact that it's being driven by our actions, and how climate will change in the future. So we see the audiences as broad. Other scientists will learn from what the experts say in their own chapters. Decision makers will have a solid reference base to understand what we know, and Canadians can go to the website, hopefully, and read what we lay out there. And we really made an intent to provide information at a high level, like high level statements that provide an overarching narrative of what climate change is occurring in Canada, and as well as executive summaries and key messages, so that we can try and target the information to people who don't have the technical knowledge to read the technical chapters, but we hope also that the science community can learn from the detailed technical report.
Maybe if I could just add a little bit, and just picking up on something that both Chris and Elizabeth said earlier. The other important thing about this report, I hope in the way that it will be used, is that it helps inform people generally about the scientific basis for our understanding of how the climate is changing and why it's changing, and that is important in order to underpin the need for action on reducing emissions. That's a clear scientific message that in order to limit warming, emissions have to be reduced. And so I think the more that people understand that this is very robust science, that the observations upon which we base these conclusions, the physical understanding that we have about how climate is changing, that human emissions of greenhouse gases, are particularly carbon dioxide, are the primary cause of changing climate. I think that's important for people to then understand why it is that we need to take action on emission reductions, and why it's important both as an individual and as a collective action that's needed.
That's for sure. Thank you. The next question will be from Carly on LinkedIn. What's one of the most misunderstood things about the report that you'd like to correct? That's an interesting one.
Yeah, great. Well,
We don't know what's been misunderstood.
yeah, I mean, it's a bit hard to say
Yeah.
what's been misunderstood. The report's only been out for a couple of
Yeah.
months. I think that some of the things that people previously had misunderstandings about, that hopefully this report helps to clarify, is the fact that climate change, although it's a global problem, it's a global phenomenon. It is driven by the global emissions of greenhouse gases. It's not uniform. So there are places in the world where the temperature is increasing more slowly, places in the world where it's increasing more rapidly. And I think a lot of people didn't fully appreciate that Canada is warming at a rate that's roughly double the global average. So that, when we started giving presentations about these reports, that was one of the things that I think, at least in my experience, people were most surprised about. People didn't appreciate that Canada is warming at twice the global rate and will continue to warm at twice the global rate. And so all of the impacts associated with the warming climate are amplified in Canada, and as Chris mentioned earlier, amplified even further in Arctic Canada, where it's more like 3 times the global rate. So I think that was maybe one of the misunderstandings that I hope this report helps to clarify.
Go for it.
Just maybe one other issue is that I've received a lot of questions about the warming that we've received or experienced to this point in time. And I think a lot of Canadians maybe didn't realize that even if we were able to magically turn off carbon dioxide emissions right now, the warming we've experienced to this point in time is something that we will need to deal with.
Yeah, that's true.
So carbon dioxide is a well-mixed, long-lived greenhouse gas. That means it resides in the atmosphere for hundreds of years, if not longer. So the warming we've experienced to date, which we know very clearly is driven by greenhouse gas emissions, carbon dioxide emissions, we have to deal with that. So really the key issue, as has been mentioned numerous times, is which carbon dioxide pathway do we go down into the future.
I shouldn't have let you pass by me. You
Sorry.
know? I should have grabbed the microphone as I was going that way. You know, I just to build on what Chris said, because I think that was again, like Greg said, it's when we were giving presentations about the results that we could see which things we were saying really seemed to raise eyebrows in people we were talking to, where we could get a sense that there was something that we found and concluded in our report that had not previously been understood. So one of these is the sort of long lifetime of carbon dioxide in the atmosphere and the long lifetime of the global warming that we already have, and that it's inevitable that more warming will occur. So our report did have, one of the big headline statements about that the warming from CO2 is effectively irreversible. And I think that was a really important message for people to hear, because it's not like, there are other environmental problems that have long legacies as well. But in terms of pollution, people often think, oh, you just turn off the tap on whatever you're emitting to the atmosphere and the problem's going to go away very quickly. And that's really not the case with carbon pollution and climate change. So the CO2 accumulates in the atmosphere. It stays there, kind of like you think of the water in a bathtub. You turn off the tap to your bathtub, the water level doesn't go down. So it's the stock of CO2 in the atmosphere. So even after you turn off the tap, the level of CO2 stays in the atmosphere, and it only is reduced very slowly over centuries to millennial timescales. So that's a message that we wanted to make sure people understood.
Great, thank you. Let's talk about forest fires. So I hope I pronounced this right. Irina from Facebook wants to know the link between forest fires and climate change.
Who wants to take that on?
I can maybe start.
Okay.
So first off, I'll point out that there was one of the co-authors of the report who has done very good work, published work in the science on how we attribute individual events like large forest fires to climate change. I'm not that person, but I will try to do justice to that work. So I think there's sort of two different things that we can have, how we can attribute individual forest fire or forest fires in general to climate change. The first is scientists can do very specific analysis of an event using climate models and other means to say, okay, what was the role of climate change in driving this specific fire? So the Fort McMurray fire of a few years ago is a good example of that. Yeah. There is published scientific papers that show very clearly what the role of human-induced climate change was on making that fire the size and scale that it was. But those sorts of, that sort of analysis takes time to do. So when a forest fire happens, the next week we cannot say instantly what the role of human-induced climate change was.
For sure.
But there has been work that does do that. Shallower snowpack that melts earlier in the spring. All of these changes that we see because of climate change are consistent with enhanced fire weather. So there's nothing going on because of climate change that should, reduce the risk of forest fires. It's all the opposite. Everything we're seeing increases the general risk of forest fires. So that's kind of the second part of the story. So there's type of work that needs to be done to very specifically attribute climate change to an individual event, but we do understand at a more prevailing general sense what the drivers and risks are moving forward.
Anybody who wants to add something on that? No?
I think that was pretty comprehensive.
Yeah, pretty comprehensive. That's good. Thank you, Chris.
And we'll be happy with you.
So BP on Facebook wants to know about near future changes. So what are the changes in climate that are projected for the near future, that is within the next 10 to 20 years?
Yeah, that's a great question. It's a Greg answer.
Right? A Greg question.
This time I'll let you pass the microphone.
Yeah, sorry.
All right, well, so in this report, we didn't focus a lot on the near-term climate. We looked at climate in the 2030s to 2050s and out at the end of the century towards the last part of the 21st century. The nearer term, like with the climate over the next decade, is an interesting mix of the climate change that is being driven by increasing greenhouse gases and internal variability. So in the past, even if there had not been any influence of humans on climate, you have, when you average over a decade, there are warm decades and cooler decades, wetter decades and drier decades at different locations in Canada and across the globe. So making predictions about how the climate will change over the next decade is this combination of making a prediction about how the internal variability of the climate system will evolve over the next few years out to a decade, and superimposed on that a change that's driven by increasing greenhouse gases. It's an active area of research. There's There are models that are being used to make decadal climate predictions. We have operationally within Environment Canada a seasonal to interannual prediction system that's also available on the Environment Canada website. You can find predictions that have lead times out to 12 months, so 1 year climate predictions. They will tell you whether, they won't tell you what the weather will be 12 months from now. They will tell you whether the average for a season will be above average, or below average for temperature and precipitation. And we typically do the same sort of things for decadal predictions. So we can make predictions with some skill as to whether the climate will be a little warmer or a little colder than average in certain places over the next decade. We didn't really talk about that in this report, but there are sources for that kind of information that people can get.
Thank you for this clarification, Greg. So Sherry on Facebook, yeah, maybe, I'm not even sure, 100% sure what geoengineering is, but it's about that. So she's asking about geoengineering, if it's something that we need to consider. So maybe you can expand on what geoengineering is, and then after answering the question.
Okay.
Go for it.
Yeah, great question. All right.
So geoengineering is the idea of manipulating the climate system, doing something to change the climate. So we're already changing the climate by emitting greenhouse gases into the atmosphere, and that is causing the climate to warm.